do it. Okay, I think I've got it. I got it in my OneNote so I can put some notes in. Get some more people in our Zoom meeting. All right, we're ready. We're going to actually see what our purpose for all of this data is, I guess. Kind of like a lot of things in software development, you know, sometimes we start at the end, what we want, and we work our way back to create it, right? So I had meetings with my Java online class last week, and some people said, the reading is just overwhelming. I do better if I have an assignment. Well, go look at the project and give yourself that assignment, and then just go through the reading to find the material. And so remember, you can always do that. We always have that option in CIS of starting at the end, what do we want, and working our way backwards. So anytime it's overwhelming like that, we can do that. And you guys did a great job on the quiz. I was telling people that were here earlier, our average score, the average overall for the whole class was about 75, and our passing score for our certification exam is 70. So woohoo, and the certification exam doesn't have those kind of detail-oriented data analysis questions that you guys encountered on the test. So it'll be a little bit more query related. So we'll see a lot more on our certification exam of actual SQL syntax than we will that data analysis material that we've been looking at. So it's going to help us tremendously in knowing how to answer every single question for everything, but we won't see those kind of particular questions really in our certification exam. It's kind of the knowledge. So we're going to look at how we actually get our data from the database. This is what our SQL code is for. How can I access this data? Whether I need to access it in a program, a C# program, a Python program, whether I need to just give the user some sort of report with all of this information on it, or all sorts of different reasons, whatever I need. How can I get that data out of that database to give it to people in a reasonable way? And how can I get data from more than one table? We know that our database has a lot of relationships built in where we need to access data from more than one table in a matched way so that we get the correct data. So how can we do that? How can we make sure that we're only getting the data we want to see? If we're looking at sales reports, we don't necessarily want to give our users sales reports for the last 5 years. Maybe they only want the last month or the last 6 months. When we're doing those sales reports, they probably want some totals and some summaries. So we're going to do some data aggregation where we're adding things up, making totals, making nice tabular cross-references for people. Sometimes we're going to need to create queries within queries so that we can really organize the data or go get dependent tables based on our relationships and then get the other data that goes with it in a separate query. We're going to look at all the different data types that most database management systems handle, and looking at how to build the best select statement, our select query. Okay. Chelsea, I'll look, I don't know. Can you send me an email so I don't forget whenever you get a chance? Chelsea's asking if we could go back and review your answers, and I didn't know you couldn't do that. So I'll sure see if I can find that option, if that's something that Cengage will let us do. Somewhere in there. Thank you. So when we're working with SQL, we're going to be working with basically a programming language. It's a language that allows us to retrieve data. But there's some different categories of SQL. First of all, we can define tables, columns, and relationships, and all of these things we've been working with, and we use the data definition language to do that. So creating tables, creating relationships, defining what our primary key fields are. When we want to actually insert data into our tables or update the data that's in our tables, we're going to use DML statements, data manipulation language. These statements are things like insert, update. Then we also have another language that's called transaction control language, where we can control how many things are related to each other that create a transaction, so that we can say all of these things must complete successfully for the whole thing to have completed successfully. And lastly, we have DCL, or data control language. And we'll be looking at each of those. Just be aware there are these different categories of SQL. They're all really pretty easy to learn. They're non-procedural. What does that mean? We can think of some other languages that are non-procedural. HTML. Can you think of any other languages that are non-procedural? What does that mean? That have if statements and loops and things like that? Not necessarily. Now, we can get into some stored procedures and things in SQL where we can implement those kinds of things. But in general, a select statement doesn't include a lot of logic. It's just basically, I want these columns, and I want the columns if the data matches this query. Whenever we're looking at SQL, also, we can see some different dialects. And that's like a different accent, right? So if I'm working on a problem, I've been in situations where I've been working on a computer problem and had to deal with somebody in another location. And if you're just typing and chatting with that person, you might not notice any difference in their dialect. But if you start talking to them and you realize they're in Boston or someplace like that on the East Coast, they're going to have a much different dialect than what we have. So even though they're speaking English, what do you call it? All of their words they say sound different, and it's going to be very hard for me to understand them. The same is true with different database management systems. Oracle has a little teeny bit different of syntax than Microsoft SQL Server. Overall, they're pretty similar and very much the same, but we might see a small difference. So here's an overview, like at a glance, of all sorts of different SQL statements that we will encounter and use. First of all, today when we get into our environment, we're going to run some scripts to create some tables so that we'll have some tables for us to use. When we look at those scripts, you will be able to see the create table syntax and how they specify what columns are in the table and what columns are foreign keys and primary keys and things like that. We also can create indexes and all sorts of other entity types within our database. Then if we want to change something, we could use alter and alter our table definition. If we wanted to completely get rid of the table from the database, we could drop it. When we're working with transactions, we can start a transaction, we can commit it and say it's done. So one transaction I like to think about is a transaction, just to kind of make people think of what a transaction is if I go get gas and I use my debit card. When I put my debit card in at the gas station, I'm beginning a transaction, right? I'm beginning a transaction with them to buy gas. That transaction is complete when I'm done, right? When I take the gas pump out and put it back up and my charge goes through. At that point, that transaction can be committed. It's done, it's finished, it's completed. If there is some sort of problem within that transaction as it occurs and it doesn't complete successfully, the programming logic could roll that transaction back to pretend that it never happened, so that that charge doesn't show up on my debit card because the pump malfunctioned and I didn't get my gas or whatever the case may be. So whenever we're working with a transaction at the database level, we can actually control when that process begins and when it ends and make sure that everything in between works properly. So when we're working with tables, you guys have seen already, we're going to be working with specific columns of data, and we know that data has a specific type. We see that in all of our different programming languages. And we know that, like we've seen for primary keys, we want to use a numeric type of data because that makes things better for us in our queries. Whenever we're working with different data types, we can influence the queries that are being run, right? If I have a data type of dates, I'm going to be able to run queries that are date sensitive, right? It can run date ranges, things like that. So whatever the data type is going to influence the query. Now we know that we have basic fundamental types of data. Character, strings, right? Numeric data. And then in our database management system, they're considering a date so important that it's a basic type of data. And that's true, because when we're working with the database, we're going to be keeping track of a lot of dates, and we'll want to keep track of when even the row might have been added to the table, or when our row was updated in our table. So lots of different dates we might need to keep track of. Now, no matter what all kind of languages we can use, different syntax, create tables, update things, the whole heart of the thing is the query, our select statement, because that's what really is important. So let's start trying to use them. Before we start getting into our actual select statements, we want to get our environment a little bit set up. They have several different test databases for us in the textbook, and we're going to be able to use these and create these, as well as get to them from the cengage problem environment. So here's one of them. Let's take a look at this. What is this schema defining?
Looks like a checkout program. Database.
Yep. Doesn't. It looks like a, he's saying it could be a checkout. You could be using this for any kind of point of sale, right? So we have a customer that has an invoice, and on their invoice they have several lines, like maybe I bought several things from Amazon. Each of those things that I bought is associated with a product table entry in our product table to tell me more about that product. And each of our products is associated with a vendor that we buy that product from, so we know how much it costs and where we get it and if we need more of them. Let's see what else is here. I'm going to come back then. Okay, so this is one database that we have, one little set of tables. So let's go out and look at our environment and see what we have. We'll jump around a little bit. So for us, we actually have some stuff outside of our cengage environment. So we're going to decide how to use our different pieces. We have a database management system, a database server. And remember, a database server is a server that supplies the services of a database management system. That database management system could be Oracle, it could be MySQL, it could be all sorts of different database management systems. Us, we have an Amazon web server that runs SQL Server. Why is that important to us? Well, SQL Server is the database management system that Microsoft sells, and that's the database management system that they use syntax from on the MTA certification exam. So that's going to be the one that we care about a lot for our exam. The cengage problems are going to use MySQL, which is a little bit different of syntax, but not much at all. So MySQL is from Oracle, and it's a free database management system. It's really popular too. So they're not very different. So we're going to maximize this and give you guys an opportunity to get experience with both of them and see if you can find any sort of differences. So our cengage environment is going to be nice to use, maybe. We'll see. We'll see how picky it is because I haven't tried it yet. And you guys might say, this is not nice, or you might say, oh, this is awesome. We'll see how that goes. So we have some choices. So our cengage stuff It's really nice because it's pre-built, right? We don't have to install any software or do anything to use it. And we can do it in a cloud-based environment. You guys can do it on your phone when you're desperate. Whereas our Amazon Web Server is different. To use it, we're going to need to install a management console. Microsoft SQL Server Management Console is going to be the software that we'll use. And we'll use this software to interact with and connect to our server. So through this console software, we can issue all of those commands, like to create tables and do queries and things like that. So we need to get that going. When we get connected to our database, our SQL Server database, each of you will have a database already created, and we'll be able to create tables within that. So we'll be able to create these same tables that they're using as examples. So let's try it. Where? On Canvas, the setup course module should have some new stuff. The first one is the Our Server page. And if you click on that, you'll see the links to download and install the SQL Server Management Studio. And you can do that at home. You don't need to do that here. It should already be downloaded and installed. We should already have it. It can be kind of a large download, but I don't know, sometimes Microsoft, some versions are much better than others. Now, once we've got that SQL Server Management Studio downloaded and installed, we can use it to connect to our server. Our server connection information is included here on this document, and it's also on the main Canvas module list. Before we go on and do that, though, I want to scroll down a little bit and show you there is a document here, and in this document, it shows you the SQL Server Management Studio connection screen, and it shows you the different things that you're going to need to make your connection to the server. So let's try it. I want to find SQL Server Management Studio. So if I look at my start menu, I have two things. I don't want this SQL Server Profiler. I want this one, SQL Server Management Studio 18, and that should be the newest one. So when you install it at home, it should be about the same version. I think it's going to open. It doesn't want to move, so let me share that screen with you instead. You can't see it. Can you see it on your Zoom session? Look at your Zoom session. We're ready to log in. Now, to get this server name, our server name is very long, and it's in a few places. First of all, it's on this document. It's up on the page in bold, and we need that whole thing, but make sure you don't get a space at the beginning of it. So we want to make sure we start with the Stu SQL. And the comma 1433 is required. So I'm going to copy that whole thing.
Mine says login failed. The login is from an untrusted domain and cannot be used with integrated company.
Zeros in your password.
Sometimes there's all of them. I just copy and paste it.
Oh, you have to change the login type to server.
Okay. I'm going to get mine pasted in here. Now you can Control A in that server name field if it won't let you select something. Those of you that have C#, we will have a separate server, so you'll have to switch back and forth. It'll keep them for you in the drop-down list after you've logged in. Now your login name is going to be your user ID. Those of you that are employees, it would be your employee ID. Your password is going to be your user ID without any leading zeros. So I pulled these off Excel, so it got rid of leading zeros for you. So you should be able to get logged in, see yours, and I can see everybody's. Your database name and your username are the same. So every time you use the system, you're going to have that set up as your database. We want the student data files, and last time we went to get them. Does it let him on? So we'll get Isaac fixed. We might have to recreate your account, or we'll figure out what's going on with that.
You want me to disconnect from his account?
Do what?
You want me to disconnect from his account?
Yeah. Yeah. So when we look at cengage, we went to the download your data files, if you remember, and we were clicking through student data files, and this time we want chapter 7. Now this is one of those ones when we clicked on it, it just disappeared, and our awesome back row expert said that's because we need to use the wheel to click and tell it to allow or keep it, basically. So I clicked with the wheel instead of the mouse button to keep that file. So if you don't do the mouse button, you're just being ignored completely. Now, once that zip file is downloaded, you can just choose Show in Folder and open the zip file, and then we should just be able to extract all. You can save this Chapter 7 Intro to SQL folder wherever you like. I think I'll save mine in my CIS250 folder. And what we want then in that Chapter 7 folder, we have several different test databases for us. So some of their examples in the textbook use this construction company, some use this fact database, a large company, and the sale company. So we could look at those and open them in Access if we wanted. So all of the ones that are the .mdb, remember, whenever I look at View, my View tab, I have my view set to details, and I have hidden items checked and file name extensions checked so that I can be sure I know what I'm looking at in these download files. Now, the MDB files are our Microsoft Access files. So any of the examples that you wanted to try, you could try with Microsoft, or with Access. Those files are supplied for you. The others that we have are the database creation scripts to create all the tables for each of the different example databases or problem databases here. And there are 3 of them for each of the different databases. So the MySQL are for MySQL. So we wouldn't need to run these scripts anywhere because that's what's already been created for us on the cengage server. The ORA are for Oracle, and we won't be using Oracle at all, so we won't need to worry about those. But the last ones, the SQL ones, those are for SQL Server. So if we run those, we can create these sample database tables on our databases so that we could use the queries and things that they offer us. So we'll be using those to create the tables. Let's try one. I want to get Isaac fixed, but I'll try one first. Now, because I've got SQL Server installed, if I were to rename this from .txt to .sql, and Windows complained at me, now when I double click this, it'll open in SQL Server Management Studio. And of course I could, well, I lied, huh? Yeah, I want to keep using this app. SSMS is the Management Studio. Did it open?
Yeah.
All right. Okay, so we have a create script here, a creation script, and it's going to create the assignment table, the employee table, and the job table and the project table. So this isn't the exact database that we were looking at. We were looking at customers, invoices, and it doesn't really tell me which one that is. So let's look at the others. I can change, I guess Saleco, that sounds like a reasonable one. I'm going to change it from .txt to .sql. That looks better.
Which one did we open?
I just opened Saleco. So the bottom one in the list of files.
You changed it to what?
Change it from .txt to .sql. There it is. So in your file system, if you rename it, now you don't have to, you could do file open here in the SQL Server Management Studio also. Now, when you double click it, it should open here in the SQL Server Management Studio. And let's take a look at where we are in Management Studio. Right now, our script is sitting in this code window. The code window has a tab up here. So if I wanted to, I could close this tab and all of this code would just go away, right? So if I save this code, I'm going to save it to a .sql file, like the one that we opened that contained it. When I look beside the code window, I see the navigation window for our database server. So in our navigation window, up at the top, we see our server name, and then we see all of the databases that have been created in our server. Underneath that, we see some security information. So each of us also has a login for our account to get into the server. Now, when I run this script, it will actually create all these tables for me. Before I do so, I'm going to expand my database over here in the left and see if I have any tables yet. So I'm going to click that plus sign, and I see that I've got a bunch of different entity types under my username, and I'm looking for tables. So I'm going to click the plus sign by tables. And see, I don't really have a lot of tables. I could expand system tables and see if I have any. Nope. It's pretty tableless. So I'm going to create some. Now, whenever I'm working with the database management system and I want to do things like this, like create tables, I can set everything up in a script like this. But I don't have to do it this way. It's just an option. Now, whenever I have code in my code window, I can execute that code by clicking the execute button. Right now, my execute button is grayed out because my current situation is I'm clicked over here in this database navigation window. I can't execute it. But if I click in the code window, my execute button enables and I can run this code. Before I run it though, I want to make sure that this transaction is going to use the correct database. So up at the very top, I'm going to open up a new line and type use and my database name. And then I'm going to put the command go. Notice at the end of the use statement, I put a semicolon.
Mine's not opening up any of the files.
Oh, okay.
I made them SQL. I was just waiting for a break, but yeah, mine,
Let's fix them.
I don't know if I,
Now, whenever we run this script, notice at the beginning it's trying to drop all these tables. We don't have these. Let's run it and see if it cares.
well,
So it sort of did, right? We got a bunch of errors down here, but it went ahead then and it did some stuff anyways. So it gave us some error messages, but it was like, I really don't care. And then we got some rows affected. I'm going to scroll down, all sorts of one row affected things. So now, do we have any tables? Whenever you're using the Management Studio, notice it didn't update dynamically. We have to use this refresh button to go out to the server and get new updated information. So I'm going to refresh, and now I see my tables have been created. So you see your tables. Now they all say, mine say DBO dot. DBO stands for Database Owner, and that's just an acronym for the person that owns these database tables. So each of us in our individual database would be the DBO, the database owner. Do you guys see tables? Did it create them? Is it showing them? Sometimes it's really, really slow. Okay, so let's see what kind of employees we have. We could do a lot of different things using the SQL Server Management Studio. Like when I'm looking at my dbo.emp, I could just like right click on it and say, select top 1000 rows. And I can let the SQL Server Management Studio do the work for me and generate my select statement, right? And that gives me all of the employees. And notice that because I just said I wanted all of those, I got every single column that's in our employee table too. So I see all of the rows, all of the data, all of the columns if I select that way. So we could create a select statement ourselves that did that same thing. Let's try it. I want to create a new query. So I'm going to push the new query button. And I want to select. So I'm going to use the keyword select. And you'll see that the select keyword is kind of SQL. That's what the basic thing we do is when we're using SQL or SQL is select statements. So when I work with a select statement, I start with the keyword select. The next thing that I'm going to have is a list of columns that I want to gather. And I can use an asterisk as a shortcut for all of the columns. Then I have to say what tables I want this query to be gathered from. So we wanted to use our employee table. So I'll say from employee. So that's a complete select statement. I start out with the keyword select, and then I list the columns I want. By using the asterisk or the star, we're saying all columns. Then we have the keyword from, followed by the table name. Let's run that. I use the execute. And we should see that same data result down here, as we did whenever we said select top 1,000 rows using the Management Studio. So we've been looking at organizing our data and how should we, what columns should be on what entities and how should things be set up and what are our primary keys. And now we finally see these entities being populated with data and things that we can do, things that we can use. Okay, so that gets us started. So as you're looking at problems and working through things for the textbook, we might have to create the other tables. So those other SQL scripts might be things that have to be run. Right now, I'm not going to run them, but I want to go back to looking at the presentation and see what else they want to show us. So we're seeing that we could build this environment using our SQL Management Studio and our SQL Server, and we'll be able to do the same exact things using their MySQL exercises. So here's our database model that we're working with. Whenever we're working with SQL Management Studio, it's always nice to have this picture, or whenever we're doing any sort of queries, it's always nice to have this picture because it reminds us what our relationships are, what kind of keys we have within our tables that connect the tables to each other data-wise. Okay, so our select statement. We saw our very first select statement, and we put our select clause in. So the select specifies the attributes. So it is a list of columns. That's the first thing that we see in our select statement. Next, we have the from clause. The from clause specifies the tables that we want to access to get our data. After that, we have a where clause. We didn't use that because we wanted to look at all of the rows in our table. We could do it really easily though. Let's switch back to SQL Server Management Studio. And I see that I have empnum is my employee number. So let's say I just want to see the information for employee with employee number 107. I can just simply add a where clause and say where amp num equals 107. And then I'll execute that. And now that's limited my results to just that specific employee row. Okay, so my where clause will limit my results. Whenever I get data back, yes?
I'm thinking it's sort of like under employee and I'm guessing I missed something about like table in.
Let's see if your tables are created. Let's share with us. I'm worried about our people at home. They're being quiet.
I'm not even in Zoom session at all.
Get in there. I will let you in. Oh, someone's chatting. They're trying to tell me problems. I'm just ignoring them. Thank you, Jackie. While he's getting this, William, did you get SQL Server Management Studio installed? Because if it's installed, SQL should use it. Yes, Chelsea, I'll post the video. William, is it opening correctly then now? Are you making sure you're viewing your file type because you might just be adding SQL before the .txt? Are you getting there?
I'm waiting for you.
Oh, of course. Okay, so let's go look at your tables because it looks like the tables aren't created. So click on tables and then click that refresh button. So make sure to click tables first. Click over here on the tables word. And now do your refresh. Okay, so we need to run that creation script. So let's find it, that text file.
Is that in the data file we downloaded?
Uh-huh. I'm sure everybody will appreciate finding it again. We're not seeing it. Can you share everything with us? He's being secretive.
Oh, I don't know why it's not sharing.
It always defaults to just secret.
We have to use our imagination for
Yeah.
what's on the screen.
What's you saying? That's what I do to the people at home a lot. Isaac, why won't it work? You guys help Isaac. Why won't this login work? It's set up. It's right. It should work. Somebody has to watch you see what you're typing. Okay, so you got your, scroll down a little bit. Oh, there's the bottom?
Yeah.
Okay, and so if you double click it, you've got it ready to open the one above, the one right above it. And now, okay, because it's got the right product. All right, now at the very top, put that use. That's right. Now let's execute. Click over here. So it lets you execute it.
I'm on it. It's not executed, didn't mean it's going out.
So give it a second.
Are the commands supposed to be capitalized?
Yeah, but it doesn't really matter. Would it let you do it? Is that what it did to you before where it wouldn't let you execute it?
Yeah, it wouldn't let me do it at all.
You're logged on.
Yep.
You're logged on. Because I just copied and pasted it into a new query window, and then it came up with that execute button. The SQL Server Management Studio works really well, and it's also rather buggy. So sometimes, if the refresh won't show you new things that you created, we've seen situations where you have to actually close out of the Management Studio and open it back up the whole way to get it to refresh. So don't be surprised if it does terrible things like that to you. It's not picking on you. It's just that way. All right, he's got stuff. So, yay. Progress, that's what we want. So now we see our basic select statement. Adding more things. Sometimes, if we're outputting a bunch of employees, we might like to see them in sorted order by last name so that we can locate people. So we have the group by clause that allows us to specify how things should be sorted. We can actually add additional control with the having and order by clauses that we'll learn later to really do even more with our query. So our SQL statement that we typed in, we could have put that whole thing on one line, but we split it up a little bit just to make it easier to look at. Let's go try it. So I could put the whole thing all in one line. I'll run it. Be no problem. Now I do have a semicolon at the end, and that is a standard for our select statements. Over the years, people have developed a preference for putting all of our SQL clauses in all uppercase. So the keyword select, the keyword from, the keyword where, those don't have to be uppercase. So I could make all of those lowercase or mixed case, and everything would run fine. So it's just a convention. So as you get out into the field, you'll work at lots and lots of companies where people have not always used uppercase for those keywords. That's kind of a newer syntax that people like. And even in our textbook, this is the first time I've seen a textbook where the table names are all in uppercase too. And so you'll see that they've followed that convention where they have all of the SQL stuff in uppercase. And then when you're working in like C# or something, you'll notice all of your database things are all in uppercase, so they'll stand out to you. Okay, so we've got a basic select statement here. We're going to start out with our columns, then what tables we want those columns to be pulled from. Then we can add a where clause if we want to limit our output results to just a few entries. So what if I only want the employee title and their last name and first name? Right now I have this star, I'm getting everything. Well, I can put those individual columns in my column list. So let's say I want emp title and emp last name and emp first name. I'll go ahead and move my from clause down to the next line and my where clause. And I can just list all of the columns or attributes that I want to be selected from this employee table for this given employee. So let's run that. That should limit us down to certain columns. All right. Let's see then. So we are doing really, really good. We've got our environment going. Most everybody's being able to access it, except for Isaac. We need to get him fixed. Now, whenever I use that asterisk to list all of the columns, that was a wildcard character, a symbol that can be used. We can also give our columns aliases, different names, because those names that our columns have are kind of ugly, and our users might not want to see them. So we can use aliases. We can calculate columns for outputs, and we can do some math problems in our SQL code as well. So here in this example, they've selected an entire table. We did that. And then they selected products here for just these specific columns. I want to see what the videos say. Let's watch one. So they're in the cengage content. And I'm going to look at this very first one under visualize, projection. And let's see what they have to say about doing our.
query to retrieve data from database tables will require at least a select part and a from part.
Oh, that's a good
The
video.
select part specifies the columns to be returned by the query, and the from part specifies the source for the data. Using the Chapter 7 Sale Code database, consider the command select star from product.
Now you should be able to do this with
This query will
him
retrieve all of the data from the
because we have this actual database. So try the select star from product because we have that database loaded up. You should be able to do these same queries along with him. And of course, you can try these at home too. Just wanted you to see what they're like.
product table. Recall
Do
the
what?
project relational operator from Chapter 3's discussion of relational algebra. Project is used to return a vertical subset of data from a table. With project, we specify the columns to be returned and the order in which the columns should be displayed. The select part of the query specifies the projection to be performed by the query.
Okay, so that's a syntax, a terminology that's not really familiar to me. And it's from our textbooks. You guys have to help. Remember that by creating this select statement, we're projecting that data because we're saying, I want this column and this column and this column, because that's a term that I'm not super familiar with.
In this case, the asterisk or star character is a wildcard that means all columns. Recall that projection by default returns all the rows of the table. Limiting the rows will require a selection or restriction relational operator, which is covered in another video. The query shown specifies that all columns should be returned from the product table, and since we did not limit the rows, all the rows from the table are included. We don't have to return all of the columns. We can specify only the columns we want by listing the columns in the select part of the query. Look at the command select pcode, pdescript, pprice from product. In this command, we specify that we only want to return the product code, description, and price columns. Notice that when the query is submitted to the DBMS for processing, only the columns that we asked for are returned, and the columns are returned in the order in which we listed them. By changing the order in which the columns are listed in the query, we can change the order in which the columns appear in the result. The following command changes the order of the columns in the output. We hope you enjoyed this video. Look for other videos for database systems design, implementation, and management.
Woohoo! Okay, let's try it on cengage. Let's see what we got. Go for it, go for it, go for it. Now, as you look through the textbook, oops, let me check this chat here. Okay. Isaac has gotten logged on. So Isaac, will you share and show everybody how to run that script again? And it won't hurt anybody to review. So I'm gonna stop share. Isaac, if you will take over, we'll walk Isaac through it. So help Isaac with this. He left and he's gone. He's gone. Too many breaks. Oh no. Try those problems on cengage. Let's see what they're like. Okay, so we've got our text file, our downloads for our chapter 7. Isaac went to the view tab. Show them the view tab, Isaac. And clicked file name extension and show hidden files so that he would be sure he knows what he's working with. And now he's going to rename that SQL.txt file to be underscore SQL.SQL. And he's going to double click on it to open it and say OK. It should have the SMSS chosen. And then he's going to go up to the very top and he's going to put use in his database name. Actually, before the first blue stuff, you can leave the comments there. Use and then your database name and then a semicolon.
The database name, like my username.
Uh-huh. And then the word go on the next line.
And semicolon.
No.
Oh, wait, next one. None of that's happening, by the way. We're using the.
Semicolon after your database name, but not after go. And then execute. And then you should be able to go to your tables and refresh. And you should see all those tables. Yep, expand your name. Yay, they're all there. Okay. Woohoo. So now we have this environment that we had to work quite a bit to create with our SQL Server stuff. And we also have the environment that's supplied by cengage. So let's try it. I'm going to take the screen back over. And this will make it easier for our people at home too, because if we do the problems on cengage, again, it's cloud-based, and so you shouldn't have to do any installations. So in Module 7, there's a new category called code, and that's what we want to look at. Let's look at this very first one. Now, notice how this chapter is going to be split up. So we're going to have the first couple that we'll work on this week, and then the next couple we'll work on the week after, and then the next one will work the week after that. So these are not all due.
There are also some regular assignments.
They're what?
There's still regular assignments.
Yeah, so you'll have 2 of these problems this week. Next week you'll have, whoops, that one, the touch screen's working, yay. Next week you'll have 1 of the SQL problems and the critical thinking, which should be just 2 critical thinking exercises. They're pretty small ones. And then the third week, you'll have the 3rd set of problems and the quiz. So we've tried to split it up so that it won't be too much, but don't think you need to start going through that chapter 7 and understanding all of that content right at once. And it's not really split up in a good way for me to say you need to do pages such and such through such and such. So let's just say there's going to be spots where we're going to need to refer back to the reading and emphasize a section to be able to complete some of the problems that we're doing. So we'll kind of let our problems guide us as to when we look at the content. And then we should be able to, towards the end, review all of the chapter 7 content without having too much problem. But there's a lot of chapter 7 content, right? Do you see what that last problem number is? So yeah, we're going to work through those together. So don't worry about it, because there's a lot of them. So as I went through, they're all pretty quick. we'll see how it's going to work. So I'm going to click on start this assignment, and I want to see how this very first one is going to come together and how it's going to work. So whenever we look at this very first problem, first of all, let's look at their environment they've built. It's neat. It looks good. Over here on the left, we have our instructions, a picture of our entity relationship diagram in each of the tables and its content of the database that it's concerned with. So again, we could get this Chapter 7 construct code and run this to create this on our SQL server if we wanted to too. So we can have this database in all these different places and practice with it however we want. But if we want to just look at it in cengage, over here on this side we have all of our instructions. Here's our query window where we're going to write our code, and down here is where our output is going to display. So it's a lot like our Management Studio, just a little bit more compressed. So as I look through the instructions, it says that our database stores data for a consulting company that tracks all the charges to projects. The charges are based on the hours each employee works on each project. So here's our structure and contents. And of course, you could click on this image to bring it up in its own tab so that you can slide it off to the side and keep it when if you've had to scroll on by. Yes, Chelsea, there's 2 due on the 20th. Now, as we continue on looking at our tables, it says the assignment table stores the job charge hour to maintain historical accuracy of the data. So that means that, like, for this job, we might have charged $35 an hour, and for another job, we might have charged $25 an hour. So we're going to keep track of that charge individually so we can account for those differences. Those charges are likely to change over time too, because we'll be either charging more or maybe charging less depending on demand. The change will be reflected in the assignment table. And also the employee's primary job assignment might change. So the assigned job is also saved. So think about that we're saving some historical information so that we can go back in time. So we have some queries here that we need to run. First of all, we're gonna blah, 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 click next step to get started. All right. So we're looking at that database that they just gave us and all that information. The first problem that we have is we need to write the SQL code to list the employee number, employee last name, first name, and middle initial of all employees whose last names start with Smith. In other words, the rows for both Smith and Smithfield should be included in the listing. Sort the results by employee number. Assume case sensitivity. Display the attributes shown in the results that they present in the figure. So we should get results like that. Well, first of all, I don't know about you all, but my instructor hasn't shown me how to select these people that just have this last name Smith or Smithfield. So I don't really know how to do that yet. I'm just learning here. So I'm going to start out with the stuff that I do know, because I'm going to build this query as I go. And I don't have to know everything to start building my query. So the first thing I need is my select statement. I do know that. Let's see if I can zoom in. Oh, a little bit. That's better. Now, in my select statement, I need a column list. All of the attributes or columns that are required. In our problem listing, they gave us these columns, but they're in a real long descriptive format, not the actual column names that are on our table. So I need to refer to that database information. So I have it off to the side. So don't forget, that's kind of what I'm referring to. So as I look at the database information, I'm going to get the column names from there. So I need the employee number. It's going to be a lot like the one we did together, huh? Emp underscore num. And then last name, emp underscore L name, emp underscore F name, middle initial, where is it? Emp. Now, where do I want to get those from? Right. Now, I know that I don't have the where clause that I need to have, but I'd like to run this query and see if I'm getting the information that they're expecting. So I've got all my employees, but I do have the right data, the emp num, emp L name, emp F name, emp initial. So in our textbook, we can go back and search for the information on how to create our where clause to limit to our last name to those that have Smith in them. But let's do that in a bit of a different way. I want you guys to go to the W3 Schools site. And we want to learn SQL. And we could start going through all of this information and to figure out how we could create that where clause. Or we could just go to the SQL where clause. That looks good. And let's see what they say. Here they're picking a specific country, a specific customer. Oh, they're saying we have some operators though. We've been using the equal sign, but we could use our other comparison operators. Or we could do this like or in. I think for our problem that maybe like might be the right choice. We want a pattern of Smith, right? That's what we're looking for in that last name. So if I think that I like, again, I can look over here at the table of contents and I'll click on the SQL like option to find out a little bit more about that. Yep, that looks like what I want. So could I use this first option and say where emp L name like Smith %? Let's try it. That looks like the best option for us. So I'll add my where clause, where emp L name like Smith. Now, if I look through my data, I need to do that to kind of make sure how it's formatted because I am going to be case sensitive here. And it looks like I do have an uppercase S and then lowercase for the rest of that name. So I'll put Smith and %sign to say anything after that pattern Smith counted as a match. Let's try running that now and see if we've limited our output. That looks good. We've got 3 rows, employee 106, 109, and 112. And if I look at the output that they're expecting, that looks correct. Do you think that we've got the right columns?
Yes.
Yeah, so let's complete that one. Woohoo! I thought, man, in cengage, there's no telling what kind of things it's going to say to us. I was like, oh no. What's it going to do? Okay, so let's look at problem 2 here. This one, we're going to be using different tables. And we're going to do a join. Wow, that's pretty quick. Let's skip it. Well, maybe we won't be able to. We're just gonna jump right in.
Can we do 4?
I'm looking here. It's like that's the only easy one you get. Well, we can do the join. We'll just jump right in. Let's go to problem 2. So whenever we are looking at more than one table for a query that we need to use, and we can't get all the data from one table. If we look at our, let me find our diagram here. If you look at our database diagram for our construction company here, we have some relationships. So we know that our employee is related to our assignment table. If we look at it, we see that for a given assignment, we have an employee number. There's our assignment table. So for each assignment, we just have one employee, right? And then we also see that we have our projects are related to assignments. Employees have a specific job code that's assigned to them. So we see that we do have some foreign keys and some primary keys within our database. And what a join does is gives us the opportunity to tell the database management system that I would like to retrieve these tables, but I would like you to honor the relationships and keep track of the different relationships within my database. So I can do that by specifying that I want multiple tables in my from clause, and then I can say how I want those tables to be connected to each other. So in my query here, let's get started, and I'm going to build this slowly. For problem 2, they say using the employee, job, and project tables, write the SQL code that will join the job, employee, and project tables using common attributes. Display the attributes shown in the results presented below. So let's see, they say they would also like it sorted by project value. So if I'm looking at this output, we need the project's name, and we can find that from our project table. We need the project value and the balance, all of those things from our project table. Then we need the employee information for the employee that's assigned to that project. And we need the job code information for the employee that's assigned to that job or project. So let's look at some joining information. Whenever we want to join tables, we've got to open a different OneNote document here. Here's some notes for us, and I want to leave these up for you guys to add to your notes so that you can start getting some ideas about joins. So there are several different types of joins. An inner join joins two related tables to generate a result set. But if we look at this picture, an inner join is going to return the data that is in both tables. So if I'm looking for jobs that have to do with employee 108 and employees that have to do with employee 108, that data would be what my result set is. Only the things that match both. That is an inner join. Now I'm going to leave that up for a second. Remember, you can do a screen grab if you want off the Zoom session, or do type in some of the inner join information there that's typed out. I would use an inner join if I wanted to look at all of the line items for a specific invoice, because I only want to see this invoice and its line items. I don't care about all the other invoices and all the other line items. So that's what I would use an inner join for. I want to see the invoice and all of the things that were on it, but I only want that one. So I'm going to join that. The next type then. This is really the type of joins that we're going to be primarily concerned with, are outer joins. In a left outer join, the table on the left side, and I really mean the table on the left side, that's the part for people to visualize. My syntax is going to say, I want to select a student and their classes from the student table. Here's the student table, table A, but I want to join classes, my classes table, to that. They should be connected on the student ID, primary key, to the class student ID, foreign key. So I have to make that connection to tell the database management system, join these two tables based on this relationship, foreign key and primary key. So my join clause is usually going to specify two key fields. Whenever I do that, then that left join is going to give me all of the students and all of the classes that are currently enrolled in by those students. There could be a bunch of other classes I don't see because no students are enrolled in them. Now, the left join is talking about this table that's on the left of the join keyword. It is that literal, okay? So it's not talking about some sort of esoterical left table. It's talking about what table did you say on the left side of the word join? That's the table that's going to be controlling our output. And we're going to see every entry from that table in our output if we don't have a where clause. We'll get all that table. That's a left join. Now a right join would be the opposite, where maybe I would say that I want all of the classes, and I only want students that are currently enrolled in classes. In this case, I would change and put the word right before the word join, and that would change the whole thing so that it would control the output based on all of the classes that were in our tables. And all of those classes that were in our tables, we would branch off and find students that were enrolled in them. Now, an outer join is where I tell the database management system, I want all of them. I want all of the students and all of the classes. And I don't care if there's students that aren't enrolled in classes, and I don't care if there are classes that have no students enrolled in them. I still want to see them all. So that's going to give me an outer join, a full outer join, and I'll see all of the data. So if we think about our data as intersecting points from our different tables where primary keys match up with foreign keys, we can see these different types of connections, of joins. First of all, an inner join gives us only the table rows that occur in both tables. Left join gives us only the rows that occur in the left table. Right join gives us the rows that occur in the right table. And the full join gives us all of the rows. Now we have about 20 minutes, so I want you to do some research on that problem, number 2, and see if you can get that join syntax working. Joins can be challenging, and it's one of those things, if you work through it and try to figure it out on your own, bring questions back with you on Thursday. I don't expect you to have a perfect solution, but try to work through the rest of these 3 problems, and then we'll go through them together on Thursday to make sure that you've got them all correct and see what you can come up with. As I mentioned, you're going to have to refer back to that chapter, to specific sections, to find the information to help you do the queries. So it's going to be a gradual process. Don't overload yourself. You know, if you've spent a couple hours on it, that's plenty of time. Wait until Thursday and we'll go over them together. But don't shortchange yourself, you know, do try. So, okay, questions before we break and everybody work on those and try. And we will figure it out together next time. Okay, I'm going to end this thing then. We've got a lot accomplished and we have a lot more to do, don't worry.